Okay, so as promised, I was going to help you with 9 and 10, which you need help with because they're different in respect to what the center of dilation is. If you look, it's not the origin. Number 9 is centered at 1, comma 2, and number 10's centered at 7, negative 2, which means the center of dilation is not at the origin. But both of these have some trick in it that you'll see in a minute, which makes them not that bad. So I figured I'd teach it to you by showing you what the line looks like on a piece of graph paper. So the line y equals 3x minus 1 has a y-intercept of negative 1 and a slope of up 3 over 1. So that looks like this. Right? A y-intercept of negative 1 and then a slope of up 3 over 1. Up 3 over 1. And then you connect your points and you get that for your line. Now you can tell if you look really closely that it doesn't go through the origin. It does miss. The center of dilation, they said, was the point 1, comma 2. So look what happens here. The center of dilation is at 1, comma 2. 1, comma 2 happens to be on the line. So if the center of dilation is on the line, then the line doesn't move. It actually stays exactly where it is. So whenever that happens, whenever the center of dilation is literally a point that's already on the line stays the same. So whatever it was, that's your answer too. And that only happens when the center of dilation is on the line. Now number 10, it's a messy version of the same idea. So look, it doesn't have it solved for y, like some of the other ones you did. So I divided by 3 on all three terms, right? And I end up with y equals negative 2/3 x plus 8/3. 8/3 doesn't reduce, which makes this problem a little bit messy. But if you follow along, you'll see what happens. The y-intercept is 8/3, which is 2 2/3. So I went up 2 2/3, which is kind of weird, right? Up 2 2/3. And then the slope was down 2 over 3. So when you do that, you end up with a line like this. Down 2 over 3, down 2 over 3. And even if you couldn't graph this perfectly on your own, look where the center of dilation is. 7, negative 2. Well, if I go over to 7, negative 2, 1, 2, 3, 4, 5, 6, 7, 1, 2. There it is again. It happened a second time. The center of dilation is actually on the line, which means that is your answer. It doesn't change. So with all the ones you did above it, you were centered at the origin, and you multiply the y-intercept by the scale factor every time. But when you have a center of dilation that's not the origin, and you find out that it happens to be on the line, your answer is just the original line itself.